Now we're looking for all numbers x, which are part of the real numbers, such that the distance between them and -3 is less than or equal to 1. So remember, when we're looking at this, we're thinking distance, and to use the distance formula for the distance between two real numbers, we're looking for the absolute value with minus in between. So we can convert this into x minus a -3 is less than or equal to 1. So what are we asking for? We're asking for all the values x, which are part of the real numbers over here, such that their distance from -3 is less than or equal to 1. So let's draw a picture out of what that guy looks like. So where's -3? Well, we'll just plot that guy on this line here. And now we need all numbers x who are less than 1 unit away from -3, less than or equal to. So what are our boundaries? Well, if they need to be within 1 unit, they need to be between -2 and -4. So any number that falls in this area is going to work. So we're going to have an interval here, right? We're going to say our solution is all x's such that x is between -4 and -2. In fact, if you pick any x in here, let's just try one. Let's grab maybe this guy here at -2.5. If you plug that back into our original equation, you'd have -2.5 plus 3 is less than or equal to 1. Let's see if this works. Well, -2.5 plus 3 is 0.5. Absolute value of that. And sure enough, 0.5 is less than or equal to 1. Again, you can pick any other number in here. In fact, I would recommend, or I would at least hope that you would try picking another value and seeing if it works. Okay, so that's what the picture looks like. So now this is our solution. We're done. Okay, now how do we figure this out algebraically? Or computationally? I mean, what we need is to be able to work with this guy. This is probably the best thing. The best thing is to be able to look at this, say, okay, what's this question asking? What values are we looking for? Well, what we need to make sure here is, okay, if this guy is positive, okay, then we just get x plus 3 is less than or equal to 1. And if this guy is negative, then we have negative x plus 3 is less than or equal to 1. The absolute value is equal to these two. It's equal to this guy over here when our x value is, let's see here, more than 3, and the other one is less. So what are we going to do? Solve this right here. What I've got to do is I've got to move this 3 over. So this is going to be x is less than or equal to. Now when we're adding or subtracting, we don't switch the sign. When we multiply or divide by a negative, then we switch the sign. So we'll subtract 3 from both sides. So this gives us -2. Now over here, when we go to solve this guy, multiply both sides by -1. We get x plus 3. We got to rotate the sign because we're multiplying by -1. And so now we'll subtract 3 from both sides. And we'll get -4. So x has got to be greater than -4. If you think about this on a number line, so this is an AND statement. Both these things have got to occur. So not only does x have to be greater than or equal to -4, here's -4, x has got to be greater than it, but also x has got to be less than -2. So here's -2, and it's got to be less than it. Now both these things have to occur at the same time, which puts us in this interval right here. And because we've got this little guy down here at the bottom, it means that we want to include, and that's why I've used the brackets. So this right here again is our solution. Remember, you write this out as -4 less than or equal to x less than or equal to negative 2.